In this example, we're going to take a look at the amount of force applied by the brakes of a car. So we have a car traveling 100 kilometers per hour, and it slows down and it takes 7.5 seconds to come to a complete stop. So let's figure out the force that acted on the brakes, causing it to slow down. And we are going to assume here that it's a frictionless surface. Obviously, that's not going to be true in practice. So we have our free body diagram, which is going to look like this. We have our surface and then our car. We have identified gravity and our normal force. And in this case, if we're moving, if our car is moving left to right, then our braking force is going to be applied right to left. So our applied force, which is our braking force, is applied backwards here. Okay, so what else do we know? Let's figure out, or let's write down that we know V1, and that's 100 kilometers per hour in the east direction. Since it has come to a complete stop, V2 is 0. And the time it takes is 7.5 seconds. So we should obviously convert our kilometers per hour into meters per second. So 100 kilometers per hour is equivalent to 27.8 meters per second. And of course, the direction stays the exact same. Next up is we're going to solve for acceleration. So we know from our previous units that our acceleration is equal to your change in velocity over time. So that means our acceleration v2 is 0 minus v1, which is 27.8 meters per second, divided by our time, 7.5 seconds. It's going to leave us with a negative value, so negative 3.7 meters per second squared. And that negative value makes sense because our car is traveling to the east. So a negative value would mean it's accelerating backwards or west. So our final acceleration, 3.7 meters per second squared west, or negative 3.7 meters per second squared east. Last, now we can actually solve for the FA, which is the applied force on the brakes. So FA is equal to MA. In this case, M, given in the question, 1,500 kilograms, and A, which is we just solved for, is 3.7 meters per second squared. That's in the west direction, so our force is going to end up being 5,600 newtons, also following the same direction as our acceleration, west.